while I'm the founder of Opscode, or a founder of Opscode, I'm not going to talk really at all about automation today. I am going to talk more about a thing called GameDay, which is a program I created, certainly not new to the world, but new to web operations, to increase availability using large-scale fault injection. And to begin, I want to tell a story about my very first day as a firefighter in Firefighter Academy. I took a brief break from being in tech to go become a firefighter, and I ended up getting pulled back into tech. But on the very first day of Firefighter Academy, my chief told me something that has changed my entire life and set the arc of my career development. He said that when you go home tonight and you tell your neighbor that you're becoming a firefighter, and you say, oh, I've got all this work to do and everything else, all they will hear is you're going to be a firefighter. And something changes for you in the world, which is that at 2 o'clock in the morning, when their kid starts choking, instead of dialing 911, what they will do is come and pound away on your door with a slumped over kid, and there's nothing on the screen. They'll come to your door with a slumped over kid and looking to you to do something. You need to do something. And he said, welcome to the other side of 911. Then he said, for the rest of your life, remember that you don't choose the moment chooses you. You only get to choose how prepared you are when it does. That is operations to me. That is what we do. We're the ones they call. We're the ones that people look to have the answers when things are broken. And we're the ones who, at least initially, make a difference in how we're prepared inside of an organization for all sorts of things. I believe very deeply that our work in operations is work that matters. It is a noble calling. And it is important to remember when we think about what we do organizationally that more and more of the world depends on the web. And so more and more of the world depends on us. And that means that we have to think a little bit differently about how we approach our jobs as the world's infrastructure shifts, and people now need us in a way that before, we were just maintaining hosts, and now we're maintaining infrastructures, and those infrastructures are the fabric of society. And so I'm going to talk to you today about how to make that infrastructure a little bit more reliable through something we call GameDay. Very simply, GameDay is an exercise designed to increase resilience through the injection of large-scale, catastrophic level faults into the critical systems that we depend on. It is part of a larger discipline called resilience engineering, which has not historically directly been applied to the large-scale systems administration space. Although there are a number of people, including John Allspaw and Artur Bergman and Paul Hammond and a number of other folks that are beginning to map these concepts. But it is not new. It's just new to us. When we talk about resilience, what we're talking about is the ability of a system to adapt to changes, failures, and disturbances. So when we say system, it's not just a host. In fact, I won't really talk about hosts at all in this talk. I'm talking about a system that is both the technology and it is the networks, servers, applications, processes, and people. Most importantly, people. So this will be on the test. So when you go away and you say, what did I learn from this? Resilience is a function of people and culture, predominantly, which is weird for a group of us that tend to kind of shy away from lots of human interaction. This is mostly about how you change people to be resilient. So in 2001, I joined Amazon as I was testing for the Seattle Fire Department. I was not planning on going back into tech. My title was Master of Disaster, and I owned website availability for every property that bore the Amazon name. Actually, I came to own it. My first job at Amazon was running the backup systems. Who here loves running backup systems? So I, like everyone in this room, hated running backup systems too, but knew how to do it. And it got me a job that paid pretty well. I was volunteering. I was doing a bunch of stuff with the fire service, which you have to do in order to get hired. It's a long process and a whole nother story. I got hired on August 20th of 2001, and on September 11th, I woke up. There's a whole nother long story, but I woke up in the hospital having had emergency surgery the night before, and I realized that as I was watching what was unfolding, there were thousands and thousands and thousands of employees of Amazon at the time who would depend in the coming days on the infrastructure that we provided and customers and so forth and so forth. But I realized that if we had become under attack, that I would need to put in place these systems and processes that I had just been sort of creating and updating at the time. And it was an interesting journey where it was the first time that I realized there might be a application between my fire service background and the tech world. That led to me working on a lot of the availability stuff, keeping site reliability up. And to truly understand it, how many of you work on websites that are, or at sites that are managing over 5,000 systems? How about over 10? Okay. One of the things that we find when you interact with an environment that is at larger and larger scale is complexity results in lots and lots of failures happening. And in the past decade, as an engineering culture, we've learned scaling up, vertical scaling has not resulted in us seeing lots of increased availability. Scaling out is what resulted in that. And the reason for that is that failure happens. In environments that we build, and as you increase in scale and complexity, we see an increasing number of failures. They can't be fully eliminated. Lots of vendors like to promise it. They're either foolish or lying. And the reality is that systems, as they increase in size, connectedness, and complexity, have an increased failure rate. The realities of this mirror a bunch of other industries, and if you want to learn everything that I started off learning, read this book called Normal Accidents. In that book, Charles Perrow said, multiple unexpected interactions of failures are inevitable. So you can reduce them, but you're always going to have failures. There's no amount of engineering that you can apply to a problem to eliminate failures. And there is a particular type of failure that is bad, or where a place where there is a lot of danger. So this is called the catastrophic potential chart. And we have in the bottom left, bottom left, we have loosely coupled simple systems. You think Unix commands. Yeah, they break, whatever, you rerun them. And all the way up here into the complex system, we have massively distributed web services with lots of moving parts. These systems tend to be a little bit dangerous. And the reason for them is that the likelihood of failure is so high. Just as an example, we have our typical nines evolution where we say, okay, well, we're 2 nines, so we have 3.5 days worth of outages for a single system. And the problem is that as we increase in size and scale, we start chaining together these systems. And what we find is that if if any single system fails, what you get is it's a multiplicative availability. So if you take three 3.9 systems together, you have a 2.9 system. Is this news to anyone in the room? Raise your hand. Okay. So in these giant systems that we begin to build, while it's important to reduce the amount of time that increase the reliability of an individual component on a system. So we want to make it so that certain things are not failing unreasonably frequently. What we find in a distributed system is it's much more important to decouple and to make things recover really, really, really quickly. There are many examples of this in our world. In this room, we're currently protected by sprinklers. So when the ceiling reaches a certain temperature because of a fire or some other thing, we don't try to eliminate all the possible sources of fire in the room, but we provide sprinklers overhead that go off when a fire starts in a room, and it's just enough to let you guys all escape. That's a lot better than making sure that nothing in this room is flammable and not having lights and not having all kinds of other things. So what we found, and really the evolution of engineering in our industry has followed, is MTTR is way more awesome than MTBF. It's much harder to get to a single system that never fails or doesn't fail very frequently than having lots of systems that can tolerate individual failures of components. So as we realized that, I was making my transition at Amazon, and I realized that there was some potential to apply the kind of fire service discipline, rigor, safety techniques, et cetera, to the fire department operating models, to Amazon's operating models, and basically kind of turn Amazon into a little bit of a fire department. So I began adapting fire service incident management processes, training, drilling, fire prevention concepts, and doing things to make individuals within the company think like firefighters. That included a lot of things which are probably better discussed at another talk, but putting developers on call predominantly for their services, so in exchange for being able to deploy really fast without a lot of process and constraint, you have to run your own services. And that meant that they had to be able to respond like our ops teams could respond within certain windows. That required training and drilling. As the organization became more complicated, larger scale, more interconnected systems, it also required us to use incident management techniques that looked basically, I used a system called Incident Command. I substituted the word command for management. So I created this incident management system, which was a word-for-word adaptation of the fire department incident command modular adaptive system for dealing with incidents. As we did this, I got some great support from executives. So Werner was my internal executive sponsor, and Bezos certainly thought it was interesting. I realized that part of what we needed culturally and systemically was a way of training and drilling people so that they would improve both the availability of their own sites and their effectiveness in working together. We also understood that there are certain types of failures that many people have a hard time conceptualizing. One of those is data center level failures. So I have lived in a world for 15 years where data center failures are a regular occurrence. In Charles Perrow's normal accidents world, it's a normal accident. I have a whole slide deck of my favorite data center failures, particularly ones where, if your company promises or if you ever say you have a bulletproof or, impenetrable database or data center, that next day you will have a bunch of taser-wielding thieves breaking in and stealing stuff out of your facility. Or it'll be on fire, or a tornado will come and knock it over. Like, that's how you invite that, just FYI. So never say that. but there were many failure types that could only be exposed using an operating model where we broke things intentionally or we waited for real disasters to occur. Just for an example, you never expect tornadoes to come, but sure enough, tornadoes come in areas where there aren't normally tornadoes. So what I did was I kind of returned to my firefighter roots. Firefighters are 75% paranoid and about 25% pyromaniac. It sounds like ops people too. And as I believe in setting a good example, that's what that looks like. So if you're going to blow fire, always wear your firefighting gear. Kids love it. So I created this program called GameDay, and I did a couple of things. I'm going to tell you about them, and then we're going to repeat through this a couple of times. So I'm going to go quickly through this first piece. So there's a preparation phase. Most of you have done this when you're doing those pointless DR tabletop exercises that you do. How many people have participated in a worthless DR exercise? Awesome. Okay. How many of you then burned the building down? Haha. So I didn't actually burn it down, but another story. There's a preparation phase where what you're doing is identifying and mitigating risks. You're saying, look, we're going to think about this. We're going to walk through. You know what? There's this stupid thing over here. Man, we really probably should take those oil barrels and remove them from our core database servers. Or we really should re-architect this particular system for increased availability, or some other thing. So this has two properties. One, it's likely to reduce the frequency of failure. You do these exercises, you apply some process, you make things a little bit better. Second, it reduces the duration of recovery, hopefully, although change tends to make more things more complex. Then you run the drill. And this is where most organizations fail. Most organizations end up doing a sort of very lightweight version of an exercise. It's not bad to do that. It's a starting place. But if you never go all the way through to a full-scale destruction, a live failure exercise or live fire, you don't get the benefit of a couple of things. The first is the confidence that you get responding to a stressful situation, recovering from an actual failure at full speed. I, as a firefighter, have been through countless live fire drills where I've been called to a place, we put out a fire, we're wearing gear, the fire will kill you, people die in training, it's an actual thing that happens. And I can only be an effective firefighter having fought fire. The second is that when you do the actual exercise, you see that there is an individual and cultural ability to think about what actually happens in an incident. One of the most common things when you do the tabletop exercise versus a real disaster or an exercise disaster, which is the same thing, is that people find all kinds of systems and processes they thought would work, and it turns out that our cell phone systems do have a single point of failure. We don't have a printout of everyone's phone number. Like, there's even the most basic things that in a drill you never capture. The last thing when you actually run these exercises is being able to trigger and expose latent defects. So latent defects are the things that, wow, there's a crying child. For the future recording, you'll never hear the child crying. Latent defects are those gotchas, those impossible. How many of you have had an impossible failure? It could never happen. Okay, awesome. So latent defects are sitting there underneath the waterline of the systems that we build. You can't discover them any other way, and they're the sort of, and then they're immediately recognizable in hindsight. Like, oh, we totally should have known that there was a dependency on that guy's desktop. But we never turn off the office network, and so we would never find this problem. Similarly, there's all kinds of these things that exist. There's process latent defects. It really spans everything you could ever want to cover. And so the way that you get the currency to do these sorts of full-scale exercises, and I'll describe one in a second, is you don't get to choose whether or not you have them. You're always going to have these latent defects. You do get to choose when you discover some of them. And so, therefore, you get to choose about how much it's going to cost you. So finding that guy's developer desktop that has that DNS dependency that he knows about, but he's on vacation and on and on and on, that's going to cost you money in an outage, or it's going to cost your organization some other thing. And so the reason you run these exercises is, well, you know what, let's run an exercise off peak rather than finding out about that on your most important traffic day. So the way that I've done this when I've worked with organizations, both at that large retailer that I worked for and elsewhere, is we start small. So understand that you're changing culture and that lots of people are going to resist you initially. So you always want to make the exercises achievable. And by that, what I mean is that little kid, so these hoses, when they're actually flowing water, they produce about, let's say, 80 to 100 pounds of back pressure. So that kid can go flying really high in the air. And so what you don't want to do when you're getting that kid excited about their future in the fire department is hurt them or scare them to death. So this is something that I, as an ops guy, have screwed up in my career, where I have always been a little bit more of a hammer. How much time do I have, by the way? Just so I know we started late. Great, awesome. Okay, perfect. So when you're working to create this, what I did and what I do is I go through the system and I find out what's the scariest thing in the organization. Like take a survey and find what's the one thing that if I turned it off, disaster, chaos, and pain would erupt. And then I make that the second exercise, but the first one is achievable. So we're going to power off this data center for 5 minutes, and then we're going to power it back on. Or we're going to shut off this one network at 2 o'clock in the morning for 10 minutes and see what breaks. We don't know what will break. And there'll be all these people that will tell you why you can't do it, and I'll tell you how to overcome that. But you got to start small. And the second thing you want to do is you want to build on those successes. So you want this kid to leave and tell everyone, oh my God, it was so cool. There was a little fire that they made in a pan, and I got to spray the hose, and I was like a firefighter. It was awesome. You do that with your developers. So you take them through and you say, look, we're going to power off this web server. You need to make sure that you've done your first part of the preparation steps. I hope you have some automation so that you can rebuild machines and sort of other stuff that we all, at the larger scale, start thinking about as kind of table stakes. But basically, you assume that you're gonna take a couple of folks and you're gonna go after something critical, but not too critical, and so you give them a little bit of a taste. Then you help them tell that story, so you increase awareness within the organization. This is something that we, at least I, as an engineer, struggled with because I always want everyone to get it right away. So I want to go from the fire hose here to everyone in the organization doing full-scale exercises. And I encourage you instead to just be like, tell your friends about how well this worked. Maybe have an internal brown bag session, do something else where, hey, we identified 5 problems by powering off that one system that one night that we wouldn't have found any other way. And so we're going to use that in order to expand out and do more and more and more of these types of exercises to find these really, really crucial problems that have been sitting underneath the to-do list for a while. What you also find is that there's a tremendous amount of fear that spreads throughout the organization. And that fear comes from, oh God, they might find that thing that I have been managing with that one override this entire time. How many have had an outage because of that one override that one dude knows about? Or chick, either way. Yeah, I've had that outage. Over time, what happens is you start building confidence. This is crucial. I said that this is about humans and culture. Making change requires something that John Allspaw calls the currency for change. There's two kinds. One is, oh crap, we've had this terrible thing happen, and for a very short window, we can make sweeping systemic change because right now we recognize things are so bad. There's another type, which is, and this is actually the much more powerful but slower type, is, oh my goodness, this thing happened. It's so much more awesome. And we learned something. We're better because this happened. And that's the way that I recommend you, unless you have had a series of really bad outages and so you have abilities to do crazy stuff for a little while, which I've enjoyed in my career. Not since Opscode, though. So you build confidence. And what happens is it becomes an internal competitive advantage. One team says, yeah, we can power stuff off all day long. Go ahead, rip it out. And the other one's like, well, we will get there. What you don't want to do is point fingers at that, well, we don't want to, those guys. What you do want to do is do everything you can. To, like, look how badass this girl is. Like, that girl is badass. She has a tiny hose under no pressure, but like that girl is fighting fire right there. That's a firefighter. And you want to turn your developers and your bosses and everybody around you and the rest of your team into that. Like, that's awesome. And you get there by making it really safe to play and ensuring that people have realistic, achievable challenges. So don't bite off more than you can chew in the first exercise. Then you move up. This is the full-scale live fire exercise. So let me tell you a little bit about this. So you've gone from working at small scale. You've taken one system, one service, maybe a couple of nodes, and you've broken them in some way that you find a little bit scary. Like, I really don't want those machines to power down. But not so scary that what you're doing is, let's say, powering off a data center. Now, you have to be multi-data center resilient in order to do a data center level failure without experiencing an outage. However, if you're not multi-data center level resilient, what happens is that you have a lot of assumptions about what a startup or a restart in that facility is going to be like anyway. So how many of you can tolerate a single data center outage right now? Okay. It wouldn't be awesome, but there's people in this room that can deal with that. How many of you would live in terror of some, let's say, security guard walking into your data center and seeing the big red candy-like EPO button and pressing it? Lots of nervous laughter. I hate that guy, by the way. I hate that guy. When I was a firefighter, my very first night as a firefighter, I was, during the day, consulting for the Palo Alto Internet Exchange back in 97, 98, 99, I don't remember. And then that night, I was a Palo Alto firefighter intern, and my very first call was a diesel fuel spill on the roof of the Palo Alto Internet Exchange. Thousands of gallons, and I sat there, and as a rookie firefighter, you don't talk, and so you're sitting in the engine, you're facing backwards, not talking. I'm like, oh my God, I'm going to a fire, this is going to be so cool. 529 Bryant Street, oh shit, I work there. And you face a moment of wondering whether or not you're going to talk, and so I click in, and they say, what, Robbins? What? And I'm like, sir, I work there. Oh, cool. So we go up onto the roof, and we're standing, boot deep in diesel fuel, and the guy that I worked with during the day had like a heart attack when he saw my face, and there is my truck captain with his arm on the massive kill switch, and I can see like the muscles rippling, right? Like, so he's gonna shut off the internet. Like, PAX at that point, like, it probably still is horrible. And I'm like, sir, and he goes, what? I go, if you shut that off, you're going to shut off the net for, like, who? And he goes, well, you're telling me that all those nerds like you are going to be all sad if I do this one thing? Yes, sir. And he said, huh, that's a lot of power. All right. So those data centers get shut off, and that happened long before I ever worked at even larger scale. So these live fire exercises, you got to deal with them. And what you do is you, for the first one, pick the worst survivable scenario you have. The worst survivable scenario, which I recommend full-scale data center power down. It will terrify everyone, and you will learn who are the crazy people and who are the awesome people. Everyone will hate you for a period of time when you're planning this exercise. It's going to be good for them, I promise. So what you do is you plan it out. You give them, let's say, a couple months, and you say, on this date at this time, we're going to power the thing down. This is for this first time. We're going to power it down, and you're going to know what facility, what time, shut it off. And so you have months to remediate all those little gotchas, all those little problems that you could eliminate. And then the week of the day comes, and you meet all these people who tell you, look, you're not really going to power it down, right? Yes, you are really going to power it down. And the reason that you have to do it is just like this fire here. You can't learn any other way. It'll be like, it might be that you identify some crucial thing that you weren't expecting, which makes you stop the exercise because, oh crap, if we do that, it will destroy everything. But there comes a point where you just got to power the thing down. So I recommend, if you have to, slip a date, but never stop doing it. Otherwise, no one will believe that you are actually going to do it again. And I have run into this multiple times. I always power it down. So if you're ever working with me and I say, we're going to do a game day, I'm always going to power it down. The first time will be a disaster, and you will learn so many things. Probably mostly about your own ability to recover. Sysadmins are terrible. Like we are terrible about maintaining our own tools the right way. Even if you have something awesome like Chef that does all of your automation and deployment, there's like you could have everything perfect, but there's going to be that ops master box that, oops, was the first machine powered down, and suddenly chaos ensues. So what happens from these outages is that you start increasing awareness. You identify problems, and in a way that could not be possible any other way, you identify things that you kind of turn into safety standards and building codes. Every one of the safety features in the building, in the room that you're sitting in, that would save your life in the event of a fire, is there because at some point somebody died. We don't actually improve building codes unless there is loss of life. It's a sad fact. We know that there's other things that are better, but lots of people had to die. Like the panic hardware on those doors is there because of hundreds and hundreds of people dying. And the human dynamic there is a little bit sad, but it's really hard to change. And so the reason you do these exercises is so that you identify the stuff that has to become part of your culture. And you get the currency to make those changes because you said, you know what, we powered it down and we found out that we cannot reboot our database masters. They don't come back up. And we're really glad we chose when we could learn that. It was during off-peak rather than on the most important day. So understand that that's the goal. There's John Allspaw has some amazing talks on postmortems. I wish that I could do a 3-hour session on how to do that. I can't in the time available. I recommend going and looking at that to understand how to conduct the postmortem after you run this and every other type of significant event as an exercise or real failures. So that's game day. So these are the three steps, or sorry, three ways it works. The prep stage eliminates the stupid stuff. Participation makes it so that people feel like they can succeed and they learn how to react in a real disaster. And the exercises find those latent defects that you wouldn't get any other way. Like you just can't know. In Allspaw's presentation, he has this rotating Swiss cheese thing where an arrow flies through the Swiss cheese holes. The walls are almost solid, but there's always this one combination of crazy failure events that gets you. So that's why you do game day. That's why it has to be at large scale. And I don't have a slide on this, but this is a technique that every large site has learned to use in some way, shape, or another. Mine looks a lot more like my fire service stuff. There are other approaches that have emerged elsewhere. But any organization that's operating at significant scale has had to learn this or perish. And so this is your job. This is that preparation thing I was talking about earlier. The upside is it can be a lot of fun. So once fires and disasters and everything else gets to be comfortable, you get to do stuff like this, where you're actually standing around in fire being like, yeah, it's no big deal. I always hate that I'm the shortest firefighter. I have a whole bunch of other slides where people, I don't like looking up because then I look tiny. But anyway, yeah, there you go. Maybe a bigger hat. So part of the reason why the human factor is so important is a thing called the OODA. How many of you have heard of the OODA? All right. So the OODA loop it stands for observe, orient, decide, and act. Right now, I have a certain amount of training experience, mindset that allows me to think differently than many of you, although more ops people in the room means that there's more crazy people. And in an emergency, I act in certain ways. And there's a guy, John Boyd, who's a fighter pilot, who described the Boyd loop. And basically, in any crisis situation, you follow a predictable response. You observe what's going on. You have to orient yourself to that. And when it occurs, you don't get to take in anything else, anything new than what you had when you came in. So there's these personal factors, your training, your philosophical beliefs, whether you've been exposed to situations like this before, that determine why and how you act. And this is about building ops culture. So what you want is you want to take people through crisis situations so that they have seen this, observed this type of situation before. They're able to orient to it. They're able to learn. They're able to say, yep, I know what's going on here, and I kind of know how I want to react to that. The data center's on fire. What do we do? If that's the first time that you've ever experienced an outage of that scale, and you've never been through a disaster exercise before, or a real full-scale game day, you're screwed. You're going to lock up. There's all kinds of predictable failure modes. Like I can tell what you'll do, and the only reason why I'm different is I've been through it a lot. As we evolve as an ops discipline, this becomes crucial. Those of you that have been in the military or in paramilitary organizations have some version of this. And basically, the orientation stage is what then allows you to move into the decide stage, to plan your course of action and then actually do things. And so the reason you run these drills and exposure and training and you're building everything up is to build that core base of competence so that people react appropriately in a crisis and think about future crises and how they can be avoided. This is often misunderstood, and it's something that organizationally matters to us because of that whole, like, we think that this is important and it's really important thing. But for many other people, like the fire department, this is something that they don't want to have to worry about. I changed my smoke detector batteries. How many of you change your smoke detector batteries every 6 months? That's more than most rooms when we do this. By the way, go home and change your freaking smoke detector batteries. So when we talk about this and we think about the way that we approach emergencies and we change culture, the reason why we do this is in part to cover those first benefits that I talked about. But in many ways, the cultural change happens because people have a shared experience base. When we talk about an operations person who is amazing, often what makes them great is they have so much in their OODA where they've got so much experience in the orientation phase that they're able to say, yeah, I've been here before, I know what to do, we're going to do this, we trained on this, we drilled on it, and that allows them to adapt and improvise to those situations. This is, as I said, part of this longer topic called resilience engineering. Great studies going across many different disciplines, and I highly recommend that everybody certainly read John's postmortem paper. and also the first book, the Normal Accidents book. So I think we're just at time, and I do want to take questions. So for 5 minutes of my talking, or 5 minutes for questions?
No, we have 15 minutes.
Oh, sweet. All right. Well, I'm going to stop for questions now because we're at that point, and I can keep going in a second. Go ahead. The postmortem reference, John Allspaw, Allspaw, and it's postmortem kung fu, or advanced postmortem fu. Any other questions so far?
Use the microphone if you have.
All right, I'll give you guys really? I told you guys to burn data center down, and you didn't, and no questions yet. Awesome. So,
what should we use for accelerants? What's the best way to burn down a data center?
Exercise planning varies, and there's one of the things that I recommend when people are kind of thinking about how to do this within their organization. There's two things. The first is there's the standard misconceptions that engineers have, where networks are always there and there's no latency. That's a really easy one to screw with. Turn off the networks. And see what happens for recovery. Add latency. Latency adding is a little bit harder, but you can do it. The full-scale power down, what I recommend is actually doing an EPO reset. So I actually recommend pressing the EPO button. And the reason is that the other failure modes are all much more graceful. And so you don't expose those, like, let's say that your RAID controller cards have some random defect that affects only 20% of them, but it means your latent defect affects, you have a 20% of your RAID controller cards will not come up when you do a reboot. Now, that would be fine if they all gracefully power down. It is not fine if you have a power outage. And that's a class of problem that appears all the time when you actually see real data center failures. Similarly, the boot up order is a thing that I recommend everybody look at pretty deeply. And the reason is that, like, if your recovery procedures depend on, say, having console access or having access to that one DHCP server, or maybe you've got that one imaging server that's connected by a single gigabit Ethernet connection and you've got 10,000 machines to bootstrap, you're going to find that problem pretty quickly. It'd be good to identify those in the planning stage, because otherwise you look silly. I've certainly looked silly many times. But that's not a reason not to, you won't find them all. That's why they're called latent defects. So my recommendation is to fully power down the machines, if you can do it. I would build up to that slowly, but that is my recommendation.
We're still in the process of moving to a new data center set. So we've actually just finished moving into two linked data centers, sharing networks and things like that.
Yep.
We're trying to plan out the actual DR test that we're going to be doing in the next couple of months. So this is actually particularly interesting. The theory currently is that we're just going to shut down the networks into the other data center, possibly even allowing for graceful shutdown of the databases as a preliminary test for the first round of these things. Just how much, the other problem we have is that they're not only our data centers. We've got 4 racks in a single data center. EPO is not an option in that case.
Well, it's not an option for you. It's still an option. It's just an option for, that's, you learn either way, right?
Let me put it this way. If I did an EPO, the entire world would hear about it.
Yep.
I mean, really, the entire financial market.
Yeah, I know exactly what you mean. The reason I say that is not you should do it, but the fact that there's an EPO button that you don't control or on the wall means that at some point that security guard comes through and it's like, oh man, it's beeping. Is this how I turn off the beeping? Oops, 5 times, and that So the way that I would approach a situation like that, one, like that's a transition where you have that currency for change, and in those circumstances, so the graceful database power down. Databases are the things that we all end up being really afraid of, and they're the place where you always end up having that one last thing that one guy or girl runs, or gal, excuse me, and the reality is that This is a time where you can probably be safer, so you can get your failover database to a much more recoverable state so that you're not exposing yourself to a tremendous amount of liability. And so what I would do is actually not do the database gentle failover. I would instead get them as synchronized as possible to minimize your data loss risk, and then power off that the one that you are failing away or moving away from, and bring it back up to see if it's recoverable and how long it takes and everything else. So you've got a second instantiation that's pretty current. So worst case scenario, you're losing a small amount of transactional integrity, which is always a risk. The way that you cover for that risk is by having a recovery point that you can move to. So those are great points where you have that currency for change.
I was actually wondering, what percentage of hardware causes failures from this abrupt?
So I always just do everything you can put in scope. You'll learn a little from a little. You'll learn more. The real lessons, the actual scenarios that expose the worst latent defects are the ones that require that full-scale scenario. So start small, like build confidence, but pretty quickly what you'll find is, you know what, the only things we're going to learn now are if we actually power it off.
I'm just curious how much hardware failure you've seen from these hard power-offs and things like that.
It really depends on the hardware cycle, which is why it's a latent defect. So sometimes nothing, sometimes, oops, there's this embedded controller failure that affects thousands of machines. And the worst part is that you only discover those when you have an event that triggers it in the first place, or you're lucky. And so, don't count on luck, count on disaster.
Well, I'm just assuming we're going to fail to the other data center anyways. So
right.
We're not using it yet. That's why it's a passive one. So
Yep.
Thank you.
Anyone else? So the human factors stuff, and feel free to come back up, and the way that organizations fail, react, respond to complex systems and their failures is universal. And so this is the other thing that it's kind of a closing lesson that I just want to pass on. So when I started doing this, I thought, one, I didn't have a community of practice around me, so I was the crazy guy within the company. I kind of turned into an operations mascot, which was both a blessing and a curse. The organizational resistance to increasing resiliency, doing these types of exercises, dealing with failure, like getting the CEO of your company to be on board with this type of exercise and testing is universal across every industry and every human dynamic. And this is a point that we collectively have been working really hard to kind of drive home to the ops community. People are resistant to change in largely the same ways. And so there's an excellent paper, a very short paper written by Dr. Cook, which is in our web operations book. And what Dr. Cook says is, this is how complex systems fail. John Allspaw and I both thought when we read the paper that he was writing about computer systems. In reality, he was talking about healthcare and how people make failures in healthcare and are resistant to change. So when we hear this stuff, it may be the first time for us, but this is a place where there has been a tremendous amount of research done. It doesn't mean that a lot of change has happened quickly, but it does mean that when you need something to bolster or support, there is likely a huge body of evidence and research and knowledge available to you from other industries where people die when there's outages or when there's a failure of a system. So I encourage everybody to avail themselves of those. That's why I'm talking about resilience engineering. John Allspaw's blog is great if you want. He's been writing about this a lot. So that's the other piece, and then I'll take the question.
There we go.
Whoa, failure happens.
There we go. Occasionally in ways you'd never expect. Have you ever tested Brownout?
Yes. two ways I've tested brownouts. One, slow degradation of machines. Fortunately, in a large-scale environment, what's cool is that you're able to start slowing machines down by just powering them off. And that tests a bunch of other things, too. You need, again, automation to do that. The other way is by throwing more capacity or throwing more load at the system. I built a system, a very basic one, to throw lots of web traffic load early on. There's now a bunch of tools like Browser Mob or SOSTA, that allow you to throw a huge amount of query load at a system and see how it reacts under high degrees of load. What I've found is it's sometimes cheaper to brown out the systems, slow down an arbitrary component, and then throw that artificial load on top of it to see what happens when the system is creaking at that scale. What you find is you play whack-a-mole with constraints. So you'll identify the first thing. Oh, it's a database problem. It's a disk problem. You'll add a caching layer. Now your load balancers fall over. So that is absolutely a good testing methodology. It's much more effective for identifying problems than which are going to move around pretty consistently. So that's in general the approach.
Well, this is more feedback. DC powered data centers,
where you lose a certain amount of power.
where your 48 volts becomes
10.
30 volts,
Yeah.
20 volts, 18 volts.
The answer is I have not done that.
We did it the hard way.
Ooh. And what happened? Something awesome?
It's fascinating to see what gear dies when and what gear is really unhappy when it dies because its voltage slowly dropped rather than disappearing.
Would you run that
i.e.
as a
what
test?
doesn't come back.
Would you do it again, or would you get value from running the same exercise again?
Not in this data center, but it's probably worth doing other places just to see what happens.
Cool.
We lose power and the generators aren't working.
Mm-hmm.
And oh yeah, the alarm system wasn't actually set up correctly to tell us
A chain
that.
of latent defects. Yep.
First notice that things were going bad. Why are we not able to ping certain components?
Yep. So, other questions? All right. I'm just going to repeat that quote one more time. You don't choose the moment chooses you. You only choose how prepared you are when it does. And thank you all for your time.
That's awesome.
I am so sorry about that.
Don't worry about it. Thank you, guys.